All right, everybody, welcome back. Day 3. So today we're going to connect a few things. We're going to connect the respiratory system and the circulatory system, and we didn't really talk about the circulatory system in depth, so I'm just going to give you a high-level overview of really what it does, why it's important, and how these two systems are related. So by the end of today, you should be able to explain the basic purpose of the heart. Why do we have a heart? Why is it important? How the respiratory and circulatory system relate to one another, and how they work together to maintain homeostasis. Remember, that's kind of the key theme that really wraps together all of the body systems that we have, is really to maintain homeostasis. All right, so if you remember back to when we talk about when we were in the muscular system, we talked about 3 types of muscle, right? Skeletal muscle, smooth muscle, and cardiac muscle. And cardiac muscle is only found in the heart. And basically the unique thing about cardiac muscle is it never stops, right? If it stops, we have a problem. That's when we get things like a myocardial infarction, a heart attack, known to most people. All right, so it does sit slightly to the left side behind the sternum. The sternum is that piece that kind of connects, and we did talk about this with the skeletal system, but it connects that rib cage in the middle. So it sits slightly behind there. Remember, when you see diagrams and you're seeing blue and red, it doesn't mean that you have blue blood and red blood. The blood is red. That's its color, okay? The blue is visually to show that the blood that's carried in that pathway, whether it's a vein or artery, and I'll talk about that in a minute, that is deoxygenated. So it's oxygen poor blood. If you're seeing something red, you know it's oxygen rich blood. So just kind of keep that in mind while you're looking for this. There's a little sac, it's called the pericardium. It's just around the heart, and its main purpose, it houses a little fluid. Its main purpose is to make sure that, because your heart never stops beating, right? We don't want any friction because it is close to the lungs, right? So we don't want, when someone has heartburn, it's not actually like, you know, their heart is on fire, right? That has to do with acid indigestion from what they ate. But we don't actually want any type of warming sensation there. Now, there's a few things. When we're looking at this image, you might notice that over here, it says right ventricle, and you're like, Miss P, you're crazy. This is my left side. No, pretend that this image is of a person facing you. So that would actually be the right side to them, okay, if that makes sense. So just put a little smiley face on that heart image. Imagine that it's a person looking at you, okay? So each side, so this is the right side, this is our left side. Each side has a little, I'm just going to kind of draw on this for a minute, has these little rooms over here. So this is an atrium, that's the right atrium. This is the right ventricle, left atrium, left ventricle. I just remember that. I mean, you don't have to know these names, but I remember that A is at the top because A is first in the alphabet before B. So basically, again, the blue represents deoxygenated blood, and I'll talk about the pathway that these things travel. Okay, so you can kind of get that. But this is called the septum. So there's this wall. Let me get this pen up and running. Maybe I can get a different color for you. There's this wall right here. All of this is muscle, okay? And that's actually really important because that's going to do the squeezing. Your heart is a pump. That is your heart's job. Your heart is to pump blood throughout your body to make sure 2 things are going to happen. The first is that oxygenated blood is going to everywhere in your body, especially your brain. That's super important. The second thing is to make sure that we're taking that deoxygenated blood back to the heart, right? And we're pumping that deoxygenated blood to our lungs so that we can get the oxygen from our lungs and that we can release the carbon dioxide through the process of exhaling, right? So quick connection of that. There are these valves over here. We'll talk about those in a minute. So these valves, if you see tricuspid, think of a tricycle. A tricycle has how many wheels? 3. A tricuspid valve has 3 little flaps that kind of open and close like a door, okay? And when you're listening to a heartbeat and you hear boom, 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 that's actually the tricuspid and bicuspid valves closing. Boom, 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 boom. Okay, there is blood in this heart in every chamber at all times. So don't think it's just like it goes here and then it goes here. Remember, this is a process where it's constantly full of blood. Okay, so I just wanted to give you that as a reminder. All right, So we see that oxygen poor blood is going to enter the right atrium through the vena cava. Now you see a superior vena cava, remember that means up, and inferior vena cava, that's below. So it's going to come into the vena cava, get pumped through that atrium. Is that the left or the right? Well, they're looking at you, so it's their right. So this is the right atrium. All right, then it's going to go to the right ventricle. Then it's going to get pumped to the pulmonary artery. Anytime you see pulmonary, it has to do with lungs, okay? Artery, I want you to think arteries. That's away from the heart, right? Arteries away from the heart. So this is going away from the heart. It's going to the lungs. Now, I could kind of guess this because I see that this is blue. So that means it's oxygen poor blood. So it's going to have to go to the lungs to get oxygen, right? Once it gets the oxygen from the lungs, it's going to go back in. It's going to go left atrium, left ventricle, and then it's going to go and be pumped in a couple of different ways. First off, we have to make sure that some of the oxygen goes back to the rest of the body. So if you look over here in this aorta, right? This is going to deliver oxygen-rich blood to the upper extremities, your head, your brain. That's the most important thing. It circles back around and behind the heart, and it's going to take oxygenated blood to the rest of the body. Remember, this is three-dimensional, and I'll show you that in a minute. Okay, a few things. If we're looking at the ventricles, right ventricle, left ventricle, they are very different sizes. Okay, now the reason why the left ventricle has much thicker, look at how thick this muscular wall is because the left side of the heart pumps to the rest of the body. So it has a lot further to go. The right side of the heart just pumps to the lungs. So if I'm going from my heart to my lungs, I'm not having to travel that far. If I'm having to go from my heart to my toes, definitely further. Let's keep that in mind. Key concept, again, we know that we're going to get oxygen and nutrients delivered to the cells through both of these working together. Remember, the respiratory system bringing the oxygen and taking the CO2 out, and really the heart just being a pump to make sure that it's circulating and helping that process run smoothly. All right, so I wanted to show you what you're kind of doing today. I'm hoping that was short and sweet and to the point. But when you get to, oh yeah, well, I'll show you a few things. This is one source I'll keep online if you really want to look at it, but it just basically shows you, these are my notes, it shows you the path that it goes through. This is oxygen poor blood. It kind of, that's why I did it in blue. You can kind of see it. And it shows you the path that it goes to the rest of the body, okay? Again, I'm just giving you this as information. I don't expect you to memorize all this because I know that we didn't really talk about the circulatory system in depth, but I want you to get the relationship between them. So that's one piece. The other piece that I'll link up there today too is just a label. And I tried to make this a little bit easier to kind of see that, this is the pathway that it travels, right? If you see the little red arrow, that means oxygen-rich blood. The little arrow that looks black has a little bit of blue on the outside, but you can't tell, but that's oxygen poor. All right, so those are my notes. Here's what I want you to do today. So if you go here, this is for today, you're going to see this thing called a VR. And so I just want you to click there. I think it's really cool. I am a nerd, you all know that. But what you can do is you can kind of switch around, if it will load, yeah, and jump through and use this grabber to kind of switch your views. And where you see that it has the eye, you can click on it and just read some information. I'm not asking you to do this with every single one. I just personally think this is cool. It gives you this three-dimensional view. This is the trachea, right? You actually get to see what the larynx looks like. You actually get to see the bronchus. You can click in here again. This scrolls down if you want to look at that more. You can do all that. But if you skip around, it gives you a close-up view of the alveoli, of the trachea. Look how beautiful those are, right? So cool. It's a lot more fun to dissect things and look at them, but this is the closest we can get for now. My personal favorite is this because it shows gas exchange. I just think it looks cool. I also like this because a lot of times we just see the circulatory system by itself or the respiratory system by itself, and this kind of shows both of them. So really what you're doing today, your like application practice piece of what you're going to do today, just explore this. There's 6 different pages It doesn't matter to me which one. The trachea one's kind of trippy. You explore whichever ones you like. Okay. So that's it for today. I hope that you are having a great